Over the years, many people have asked for a detailed video showing how to properly remove and replace the NEC D72068GF found in the AKAI MPC 2000 Classic MIDI Production Center. Recently, a customer brought one in for repair, and diagnostics confirmed a failed peripheral interface controller IC. In this video, I'll walk through the correct process for safely removing the chip, preparing and cleaning the board, and installing the replacement device. This controller plays a critical role in the system. It manages communication with the floppy drive for data storage, as well as the buttons, pads, jog wheel, and LCD interface. Without it, the MPC will not boot. We'll begin by preparing the system board and protecting the surrounding components from heat exposure. To prevent thermal damage, the nearby devices are carefully shielded before any rework begins. Here, multiple layers of folded aluminum foil are used to create a protective barrier. An additional layer of aluminum heat shield tape is then applied over the foil to further isolate the surrounding components from direct heat. This ensures the rework process remains controlled and localized to the target IC. The board has been preheated to 100 degrees Celsius or 212 degrees Fahrenheit. This process reduces thermal shock to the board, prevents warping, and makes the extraction process quicker. Now let's apply flux around the chip, making sure to cover each pin. The hot air station's temperature is set at 400 degrees Celsius or 752 degrees Fahrenheit. Airflow is set at medium-low. Watching the pins change color from a dull silver to a shiny mirror-like appearance is a general indication that the solder is in its liquid state, and removal is now possible. This chip is defective, so there is no need to focus on properly distributing heat to the chip to prevent internal damage. With a digital thermometer, we check to ensure the system board does not reach over 350 degrees Celsius or 662 degrees Fahrenheit. Let's apply more flux in preparation to remove the old solder. Here, I will be using the Lexavon LX770 butane soldering iron, as its working temperature can far exceed the temperature required to remove non-lead solder. If you're interested in this kit, it can be purchased on Amazon. I will leave a link to it in the description. We will check the system board's temperature before we clean off excess flux and solder residue. Using 99% isopropyl alcohol and electronic cleaning swabs, we will remove all flux and solder residue. Applying new flux to the pads will allow an even flow of solder across each contact and minimize bridging. However, if bridging does occur, just add more flux, then reflow the area with the soldering iron, as you will see. Once again, we will use the 99% isopropyl alcohol and the electronic Q-tips to remove flux and other residue. It is time to apply a fresh layer of flux to the pads, preparing them for the new IC. Over the years, I've found that adding this flux makes it easier to position the IC, as its jelly-like composition and sticky texture acts as a light adhesive, allowing proper placement to each pad. Be sure to align pin 1 on the chip with the pin 1 circle located on the system board. This is a crucial step, as soldering the chip upside down or in reverse polarity can cause instant permanent damage and could also explode. The tool you see here is just a device I created to hold the chip in place while I solder a few pins in position. Once they are soldered in place, the chip holder will be removed. Adding a tiny amount of solder to the iron's tip, then apply it to the outer edges of the legs will fuse each leg to the pad. Now it's time for cleanup. Using a soft bristle toothbrush and 99% isopropyl alcohol, we will remove the residue between each leg and clean up areas around the board. The process is now complete. At this point, the chip has been properly addressed and we're ready to move on. Now it's time to carefully remove the heat shielding from all nearby components, making sure you don't disturb any of the surrounding parts that may still be warm, and clean the outer edges of the chip and areas where stray flux flowed. Zooming in to confirm each pin has bonded to its respective pad. Everything looks good, and the unit is now ready for functionality testing. Thank you for watching, and if this has helped you in any way, please like, comment, and subscribe to support the channel.